Okay, it's the top of the hour and we'll get started. Welcome to an Next Generation Science Standards webinar in Earth Science. Today's webinar is hands-on learning about the atmosphere in the new NGSS-Aligned Globe Weather Curriculum. And we'd just like to remind those of you who came on, please keep your video and your microphone muted. We will be using the chat box this evening, so click on the chat window to open it up and make sure you know where that is at. Also, if you click on the participants box, you will see that you have the ability to raise your hand. We'll ask that if you have questions, you put them in the chat box, and we will have time to answer questions at the end, but we may also answer some questions during the webinar, depending upon if the presenters are interested in taking questions at that point. Next slide, please. This webinar is being recorded, and the webinar is organized by Aida Awad, who is the NAGT past president and also secretary and treasurer of the organization, Ed Robeck from the American Geosciences Institute, and myself, Carla McAuliffe, who is the National Earth Science Teachers Association Executive Director. Andrew Haves is also doing our technical support from CERC and NAGT this evening. Next slide, please. I will turn it over to the presenters to welcome themselves, but I did want to let you know that we will have discussion and Q&A at the end, as well as a post-webinar survey.
Hello, my name is Melissa Rummel, and I'm an educational designer at the UCAR Center for Science Education.
Hi, I'm Emily Snode-Brenneman, and I am also work here at UCAR, and I'm a program specialist.
Thanks for joining us today.
We'd like to let you know that we have some upcoming webinars this fall, and watch for the announcement of our programming sometime this summer. And we hope you have a great summer break. We'll start back up again in September. As I said before, please feel free to type your questions into the chat box during the webinar. And with that, I'll let you all take it away.
All right, welcome to the webinar. Thanks for joining us today. Today we'll be presenting Globe Weather, which is a new 5-week curriculum for grades 6 through 8 to learn about the weather. The complete curriculum is available to download for free from the Globe Weather website, which we'll talk more about towards the end of the webinar. And myself, Melissa Rummel, and Emily Snode-Brenneman will be your hosts. In case you're not familiar with us, UCAR, the University Center for Atmospheric Research. We are here in Boulder, Colorado, and if you're not familiar with us, head over to our website and check out the Learning Zone, where you can see all kinds of content information, classroom activities, interactives, videos, and games used for teaching about Earth system science. We'd like to hear a little bit about you guys today. Some of you have already chatted in there. If you haven't yet, let us know where you're joining from today, how you're connected to education. Are you a classroom teacher, informal educator, maybe a professional development provider or an instructional coach, or a content specialist at your district? And what is your interest in globe weather? Do you teach weather to your students currently, or are you considering teaching weather? We'll give you just a moment to type some things into chat just to let us know a little more about yourselves.
Let's see.
Oh, we have a globe trainer. Welcome.
And then Mimi, 8th grade science.
8th grade science teacher.
And Miriam's from Tucson, Arizona.
Welcome from Tucson. I think I saw someone was from Connecticut maybe, and from Maryland, from Arkansas.
high school teacher, biology and chemistry.
Perfect. Okay, so it looks like we have some teachers and some professional development providers with us today. Well, I think that this will be very informative for you, and I hope that by the end of this you feel pretty comfortable with our new curriculum and maybe can feel ready to teach it. All right, so let's just go ahead and dive in to get a look at the curriculum. Just to let you know a little background, this was developed over 2 years and was revised after 2 national field tests to get us where we are today. So it was a pretty large project with lots of different team members, and Emily and myself are just 2 representatives of this large team. So thanks to everyone who's been involved in the development of Globe Weather to this point. It's aligned to NGSS, so this curriculum came about as a response to a need to provide curriculum to meet the NGSS standards, as many states and districts are moving towards adopting that. Raise your hand if you're familiar with NGSS or if maybe you're using NGSS in your district. Again, the raise hand feature is in the participants box. If you click at that at the bottom of your screen. Yeah. Looks like we have a couple people using NGSS. A few more.
1, 2, 3, 4, 5.
Okay. Yeah. So it looks like at least a third of us are familiar with NGSS or using it. If you're not yet, it's definitely something you'll be hearing more of in the world of science education for sure. This curriculum implements a lot of the practices, so things that kids do to be scientists, to communicate as scientists, to practice being scientists. And these core ideas and cross-cutting concepts are weaved in there. We use a storyline approach so that we can sequence the learning in a logical flow from beginning to end. So we're connecting what we've just done to what we did before and to what's coming next. We focus on phenomenon, which is the way to present surprising or interesting things that students have experienced, but maybe can't explain super easily. The students' experiences in the curriculum are focused on data analysis, drawing and writing on graphs and maps and weather charts, which is one of the NGSS practices. Modeling, making different types of models, working models, consensus models that we make with our group and revise. We use physical models, as well as tracking NGSS, as NGSS suggests, tracking our model ideas. And we have connections to the GLOBE program, which is one of the most unique features of this curriculum. So using the GLOBE protocols, students get to collect data to use in their investigations or analyze data sets collected by other students who are part of the GLOBE program. And GLOBE is a program that's supported by NASA. When we look into our curriculum, you can see that it's organized around these different sections or chunks. We have an anchor phenomenon, which exposes us to an unexpected storm. So something that happens that's not easily explainable, an extreme rainfall event. We think about how that impacts a community. And then we move into each of our learning sequences where we build our learning through first considering short-lived isolated storms, thinking about what do we need for a storm to form. Then we expand our view a little wider to look at storms over a larger region, frontal storm systems. And then finally to consider how are weather patterns around the world and what causes those? So how and why do storms move around the earth? And then after these explorations, students apply their learning to a new kind of storm that we haven't talked about yet, a snowstorm, as a way to practice what we've just learned. Throughout the curriculum, there are assessments built in. At the beginning of each section, there's background information. We bring up the standards that are addressed at each point, the NGSS standards, and also misconceptions that might exist commonly among students with the concepts in each lesson. And also these connections to the GLOBE community. So let's go ahead and take a look here at our anchor phenomenon, where we consider what happens in the atmosphere to cause a storm. We're going to watch a short clip of this video. It's about 2 minutes long.
We have this unique topography, steep terrain, and a lot of rock, so you don't absorb water. We do have weather patterns that can introduce a lot of rainfall and fast-moving water that can cause a lot of flash flood problems quickly. We saw some cooler weather coming in. This weather pattern wasn't anything of huge note. It was going to be a welcome relief from a heat spell.
It has been pouring here all night, and it's still coming down. Some areas have gotten as much as 6 inches of rain in just a few hours.
Boulder County, Colorado, foothills. Man, we've been getting rained on up here. Never seen anything like it.
When you hear all this stuff about the 100-year flood and the 500-year flood, that's important because we haven't lived here that long. Our understanding of what is likely to happen is based on what has happened in the past.
One of the worst natural disasters in Colorado history occurred last night west of Loveland. Torrential rain sent a wall of water down the Big Thompson Canyon.
It was a storm that sprung up all of a sudden, and people had little to no evacuation time.
Many escaped by climbing the steep canyon walls. Others were swept to their death.
Well, there were 139 people who lost their lives in one day up there. Lots of people had built down in the floodplain.
All right, so this was a real weather event, something that happened in 2013 in Boulder, Colorado, a storm that lasted for 7 days, dropping over 15 inches of rain, causing about $2 billion worth of damages. So when we investigate a real weather phenomenon like this and highlight how the weather impacts our lives, it motivates students to explore further so they can understand what causes events like this Boulder storm to happen. So we use this as our anchor phenomenon to move us into exploring what do we know about storms? What do we think causes storms to happen? And how might the storm have happened? So we introduce now the driving question board, where students will generate questions and post them on a wall or somewhere public in the classroom, and we'll refer to those throughout the unit. So just want to remind you guys, if you have any questions as we're going through, to type those into the chat. We'll do our best to attend to them. Oops, sorry. So we'll go out into our first learning sequence where we look at what causes an isolated storm. So we're looking here at storms that happen just in one afternoon in one place. We want to be able to tell the story of the Colorado storm, that unusual storm. So a logical place to start is by observing what causes storms in the first place. So in the first part of our lesson here, we focus on your typical afternoon storm, an isolated storm, and we watch a time-lapse video of a storm forming so students can see how the day begins and how it ends. And next we go outside to actually observe our sky. This is our first opportunity to use the GLOBE protocols, the GLOBE Cloud Observer. Has anybody used that before? Raise your hand if you're familiar with GLOBE Observer. And if you're not, GLOBE Observer is an app that you can use. Anyone can use it. You don't have to be part of a school. Oh, looks like lots of people have used it. Great. So this is citizen science. It's a way to, record our observations in our place and our time about what we're noticing. But students can use the GLOBE Observer app or just the GLOBE protocols. There's some data sheets students can use to collect data. They don't have to use the app, but it is pretty fun and students enjoy doing that. So we encourage you to do that if so. And if you're interested in learning more about GLOBE Observer, you can head over to the GLOBE website to check that out. So we go outside to observe our sky to see what we can learn about storms and weather by watching the clouds. And from there, we need to think about, how does temperature relate to cloud formation? We know that clouds are a sign of weather, that during a storm, there's water in the atmosphere. So we begin to investigate how that water gets up there. And we start with temperature. So students will watch a weather balloon launch and do a simulation of weather balloon launches to see how air temperature changes as you increase in altitude. And then we'll examine some graphs of surface temperature and air temperature that were collected from some GLOBE students. Or you can use the protocol to collect that data yourself with your students. You just need a thermometer and one of those handheld infrared temperature detectors. and you can collect your own data. But if you don't have those tools available, you can use the data set that we provide. But really, we're starting to bring in our understanding of the water cycle here and how moisture from the ground might get up into the sky. So we need to understand how temperature relates to the formation of clouds. Next, we need to think about, well, what's different about a sunny day and a stormy day? So we're thinking about what causes those clouds to form. We know that lots of days are warm and not all of them result in a storm. So looking at some data, we'll go ahead and launch our first poll question, which is, when did the storm occur? We've got some air temperature data and humidity data from 2 different days. One of them had a storm and one did not. You can see the sunny day has the little sunshine next to the data, and the stormy day has the cloud. So looking at that data, when did the storm occur?
You can move your poll window if you need to see the graphs at the same time. You can just click it and slide it around.
So I'm not seeing any poll data.
We have about 64% who have voted, so maybe we'll wait just a few more seconds.
Thank you.
Okay, you should see the results now.
There they are. All right, and it looks like about half of us were correct. Yes, just before 6 p.m. And we can tell that because we see this spike in humidity right there. So as the humidity gets, very, very high, the relative humidity in the sky where the clouds are reaches 100%, and the clouds are no longer able to hold onto that moisture, and then the rain begins. So we see on our sunny day, we don't have a high enough level of humidity. So we learned that in addition to needing to have temperature, a nice warm day where the sun can evaporate moisture up into the sky, we also need to have enough of that water. We need to have a source of moisture nearby. Here you can see on the graph where we see the storm. So then we move into wondering about, why does warm air go up and cool air go down? And students investigate warming with a mylar balloon to watch it rise as warm expands and sinks as air cools. They do an interactive reading to learn about what is different on a molecular level between warm air and cool air. And we begin exploring density, air pressure, convection. Lots of us know that warm air rises and cold air sinks, but this series of lessons allows students to really explain why that is, that air behaves in these ways. And then we'll go on to a simulation of making a thunderstorm, a way to apply all of our learning about what's causing a storm to form to see if we can make an ideal thunderstorm. So now we have our second poll, which is, what are the ideal temperature and humidity conditions high up and near the ground to make a thunderstorm? So we focus on this idea that we need temperature and we need humidity, and that temperature changes as we go up in altitude. So I'll give you a moment to read over your selections there, and then we'll go into the simulation.
About half of you have voted. See if we can get a few more. Okay, 68% have voted. And here are the poll results.
All right, nice job. So looks like most of us are on the right track here. 62% chose answer selection 4, which is low level temperature should be warm, high level temperature should be cold, and the humidity should be high. So let's see what that looks like. When our low level temperature is warm, and our humidity is high, that means we'll have a lot of evaporation at the surface. We've got a moisture source nearby. And then up in the sky, it's cold, so that condensation happens. We should see our storm, and we'll hear something too.
Congratulations, you've made a big storm. Choose other combinations to make smaller thunderstorms.
So with this simulation, students can try these different combinations of humidity and temperature and see different kinds of storms that result. Notice that if we, maybe just have situations like this.
Try again. Did you know that a thunderstorm needs warm, humid air near the ground and cool air above?
So if we don't get the conditions correct to make a storm, we get prompted to try something else. So this webinar is pretty fun. Sorry, this interactive is pretty fun. Let's see here. All right. So we move on to our next learning sequence where we expand our view and look at storms over a larger region over a few days, because we realize that the Colorado storm in our anchoring phenomenon is not fully explained by an isolated afternoon storm. So there must be different kinds of storms, and we want to shift to look at these storm fronts. In lesson 8, students interpret data with temperature, humidity, and this time also wind speed. We didn't show temperature this time because we looked at that before, but students are going to analyze data over several days versus just the day of the storm, which we did before, to consider atmospheric conditions before, during, and after a storm. Students use the identify and interpret strategy from BSCS to analyze and interpret the graphs. They call out what they see, what it might mean, and they start to draw meaning from the data here. Here we see, we see that the storm happens on the 21st. We see a spike in humidity there, followed by low humidity after the storm is over, and an increase in wind speed leading up to and even after the storm. So students start to recognize patterns in data that show the storms. And now we'll go to our density tank demonstration. Since air in the atmosphere behaves a lot like fluids, we use the warm and cold fluids. The red fluid is warm and the blue fluid is cold to demonstrate what happens when a warm air mass and a cool air mass meet at a front. So this is our third poll question to describe the interaction of warm and cool air masses along the front. What's really happening when cold air and warm air meet?
Okay, just a few more seconds there. 64% of you have voted.
All right, so the correct selection was that the cold air mass spreads out along the surface, forcing the warm air mass, S mass, to rise. So this is included in the curriculum as a video, but we encourage you to actually do this demonstration with students in your classroom if you have a plastic tank that you can do this kind of activity with. From this, students make a model, and making models is something that's consistent throughout the Globe Weather curriculum. We're just showing you one example now. This is just a model drawing where students represent their thinking. We would have them do this independently and then revise their models in small groups and then create a consensus model as a class. So we start to tease out these big ideas that we need to keep track of throughout the unit, and we record these on our model idea tracker. These are things that we refer back to from time to time as they demonstrate how our learning is building as we move through and we're experiencing different aspects of weather that play into this bigger understanding. So this is an example of some student work on one of the models that they drew to explain a weather front. In lesson 10, we explore why storm fronts move in a particular direction. So now we're going to do analysis of weather maps focusing on pressure differences. And the idea that a storm moves towards low pressure areas and that warm rising air creates these low pressure areas, whereas cold sinking air creates high pressure areas. This is also the opportunity to measure barometric pressure using the globe protocols. And if you have a barometer or an altimeter, you can do that. So students will have this data, this weather map in their activity sheets, and they'll be encouraged to draw and label on there to see which way the cold front is going. And we can tell by looking here where the low pressure lines are, right along that blue line is the front, and the little triangles would point in the direction that the front is moving towards. So in this case, the blue triangles would point towards the right side to indicate that the storm is moving towards the low pressure. So now we circle back to our anchor phenomenon to see how the story of the Colorado storm is unfolding. And we realize that though this was definitely a storm front because it lasted for several days, it isn't typical of frontal systems. So this storm stalled for several days. Adding in the weather report cues students into the effect of the mountains. So now we realize that topography of an area can influence the weather as well. We see that this storm that happened in Boulder, Colorado is kind of unique. And now we're ready to think about where else does unique weather happen. So we consider worldwide weather. We move into learning sequence 3 to consider how and why storms move around the Earth. We're going to watch this video, which is a NASA video of annual rain and snow. And I'm wondering, what patterns do you notice? So if you wouldn't mind, please type in the chat your thoughts. What patterns do you notice here? Remember, our motivation here is to consider global weather patterns. We can see where we have like yellow or red or orange. Those are areas of high precipitation. So what patterns are we noticing? Does everywhere have the same amount of storms, or do some places have more storms than others? Some of us are noticing that the storms move in different directions depending on where you are on the Earth, if we're near the equator or we're near the poles. We've got equatorial movement from right to left. Yeah, so we definitely notice that there's patterns in the movement of storms, and hopefully now we're wondering why. So why is it that we have these patterns of movement? So we think about this idea of, well, we know we need temperature to evaporate moisture into the air, and we know that some places on the Earth are hotter than others. So this leads to our final poll question today. Why is it hotter at the equator than other places on Earth? Go ahead and take a moment to vote. We definitely noticed in the video that there was more storms near the equator. If you happen to live in an area where there's any hurricanes or large storms, it'd be a good opportunity to bring those up based on your location. as you're answering, I'll just point out that this idea of why it's hotter at the equator than other places is actually one of the many misconceptions that are part of our understanding of weather. A lot of people have not quite the most accurate understandings of why it is that the equator is warmer than other latitude locations on the Earth. And there's lots of misconceptions with weather, which is one of the reasons it's so challenging to study weather, to teach about weather. And we try to point out where these misconceptions might live so that you can be aware of them with your students throughout the curriculum. All right. So it looks like most of us are on the right track here with 90% of us choosing answer B, which is the angle of sunlight is most direct at the equator, thus solar radiation is most concentrated there. Unfortunately, there's a lot of people that still believe that the equator is closer to the sun than other places on Earth, but while the equator might be slightly closer, the amount of distance is so negligible, it's not enough to cause those differences in temperature that we see. But we see that these misconceptions are prevalent among most people in our society, and it's good for us to have an opportunity to point them out with students as they're learning about weather so that they're not confused moving forward. Okay, so to test this out so that students can see maybe why it is that it's hotter at the equator than other places, we do an investigation to observe energy angles. Students discovered that sunlight is spread out across a larger area as your location on the Earth moves further from the equator, which means that the amount of energy received from the sun is greatest at the equator and diminishes as you move away. So students take a graph paper and a clipboard and a flashlight, and they draw a circle to delineate where the light is illuminated. And then if you hold that same piece of graph paper at an angle and shine the sun down, the flashlight, of course, representing the sun, we see that that circle spreads out, and that same amount of light energy is spread over a larger area, which helps students to understand that it won't be as hot somewhere where the sun's radiant energy is spread out over a larger area. The final pieces students add in here are with lesson 14, observations of a convection tank demonstration to create a model to explain air movement on a global scale. So this is where we talk about the Hadley cells, this idea that low pressure at the equator where it's warm causes rising air, and then sinking air where there's higher pressure at the 30 degrees north and south at those mid-latitudes create these convection cells, moving air around the tropics. We focus on the tropics. But then also this idea that storms don't move just directly north and south, as we saw in the video, they actually curve. And this direction of curvature has to do with the spinning of the Earth. So in lesson 15, we learn about the Coriolis effect, and we use a simple physical model of a balloon to draw on the balloon when it's spinning, that it's impossible to make a straight arrow north to south when you're spinning the balloon. It curves, just like the winds and the storms curve around the Earth. And then we'll move to our culminating task, where students apply our learnings about weather and storms to a new type of storm, a snowstorm. And ultimately, students there predict, where will we have a snow day on February 24th? So we go through 3 different challenges, challenge 1, 2, and 3, and we follow the same storm as it moves across the United States, starting on the west coast. You can see here the location of the storm front on different days. We notice where it snowed. We notice differences in humidity and air pressure. And we pull it all together to think about, on this next final day, February 24th, where will students have a snow day? All right, and I'll hand it over to Emily now.
All right, thanks, Melissa. So I'm hoping that after you just heard all this wonderful knowledge and everything about globe weather, that it's a great teaser, that the next question on your mind is actually, well, how can I get my hands on a copy of this curriculum, or how can I share it with my fellow educators? And more importantly, how can I do this for free? And we are very, very excited to share with you. Globe Weather has a website, and it is globeweathercurriculum.org. And we really tried hard to have a wealth of resources on the site that go beyond just a typical PDF download of the curriculum. We wanted to make sure whoever wanted to implement this curriculum had everything at their fingertips in order to do so. And so we're going to do a quick tour of the website through, and really what I'd like you to do, if you are a tactile learner, I have some just some snapshots of screenshots of the website that I'm going to be going to. But if you're a tactile learner and love to click on things, feel free to navigate to the website now. I don't want to slow anyone down if they want to start playing with the website and looking at things right now. Like I said, it's globeweathercurriculum.org, and when you arrive at the homepage, you have a variety of options to navigate to different parts of the curriculum. And a great place to start is with the overview of the curriculum. And with this overview, it tells you, Melissa did a great job of summarizing everything. This really goes into the nuts and bolts of what globe weather is, how to use it, as well as a materials list of what you need to get started to do this in your classroom. We also have testimonials at the bottom of that page from our field test teachers. So if you wanted to see what other teachers that have used this, think about this curriculum, you can go ahead and read that there as well. There's an opportunity to download the entire curriculum as one PDF, and that is located at the home page as well. However, we wanted to be really flexible since this is a really large curriculum. It's 5 weeks long, well over 250 pages. So we want to give a lot of flexibility to how you want to use this curriculum essentially. And so we have a table of contents, and you can navigate there in 3 different ways from the homepage. You can, up at the top, there's a tab called Curriculum that you click on that, and you can get to our table of contents. Also within the elements of Globe Weather, there are different hyperlinks to get to each of the sections of the curriculum, as well as a table of contents hyperlink in the box in about the middle there. And when you click on the table of contents, what comes up is you can access that overview of globe weather again, as well as go to the anchor, go to the learning sequences, culminating tasks, as well as the assessment section. And if you notice there is little lesson icons, you are able to click directly on those lesson icons and get to the specific lesson resources as well. So when you arrive at a particular section of the curriculum, you will see a wealth of resources. And for example, we're looking at learning sequence 1 right here, and you'll notice that there's resources. And these at the top, the resources that are pretty general to that learning sequence. So you start off with the teacher guide. And within this teacher guide includes an overview of the materials, step-by-step instructions for activities. So it's really your guide to how to go through and move through and lead your students through learning sequences. We also have all these student activity sheets for that particular learning sequence or section as one PDF. So if you want them all in one place, or if you have your students using, for example, if you have a science notebook and you want all of them at once and you want to give them all learning sequence at one time, you can do that. We also have PowerPoints for you to download, and these help organize and guide your students through lessons and activities. If there are any type of assessments with the learning sequences or sections, those are also listed here. We have pre-assessments for our anchor, and then we also have summative assessments for our learning sequences, and a final assessment associated with our culminating task as well that goes after that. And we do also have an assessments separate web page that has all the assessments in one place, so you don't have, it's just another way to navigate to our assessments. And if you want to go even further and connect to the GLOBE community and do more with GLOBE, we have a web page for each of our learning sequences called GLOBE Connections. And this is just another way to extend your lessons and get your students involved in GLOBE. Within the teacher guide, there is a lot of additional background information for you. There are a lot of links listed there, and we did list them on this website as well. So if it's easier to click on a link a lot of times than it is to just, if you have a printed copy, you have to then type it in. So we wanted to make it easy for folks to get to the background information that they may or may not need. And just when you thought you had it all, there's also more resources for every single lesson. So as you scroll down the page, you'll see each lesson and everything that you might need underneath that lesson. So if you want to break out your student activity sheets for just that particular lesson, a lot of classrooms these days are one-to-one. So you may be able to have your students just open up that activity sheet directly from the website. There's also the links that are used within that particular lesson listed, as well as your GLOBE activities and resources. So we wanted to really make this accessible, and however someone wanted to implement and use this curriculum, we wanted to give a variety of options for you to do so. So this was a really quick overview of the website, and so I really highly encourage you to visit globeweathercurriculum.org and just explore all of the resources. And this was just launched last week. So if you notice anything, or if there's anything that you're like, well, this could be really great, or this is a little confusing, please feel free to reach out. I do love feedback. We want it to be usable for folks. So if you find something that needs tweaked, or just have a suggestion, we can look into it and see if we can make it happen for you.
Melissa, I couldn't get to it through globeweathercurriculum.org, but found it under globe-weather-curriculum at UCAR. Is it moving, or?
It should not be moving. We just tested it yesterday with globeweathercurriculum.org. We were having, there was something with the security, the certificates. We were working through that yesterday, so it might be doing something odd again. There's another way let's see.
Yeah, I put in the chat the scied.ucar.edu/globe-weather-curriculum, and it had everything you showed.
It looks like other participants are finding it okay through globeweathercurriculum.org. So, okay. Yeah, but we'll look into that. Thanks for pointing it out.
Yeah, thank you for letting us know, because we were finding that that certain people that had maybe, that were working for NASA or things like that, they were having a little bit more difficulty. So we're still working through that because it is hosted on the SciEd website, and we're just trying to. We wanted to give a redirect to that site, and we just wanted to use globeweathercurriculum.org. So if you are having issues, please do let us know, and we can troubleshoot those and try to figure out what's going on for sure.
Any of you who are teachers out there, do you teach in, do your students, are you a one-to-one classroom? Do your students have access to tablets and computers? You could go ahead and raise your hand if you are one of those schools, or type in, yeah. So I think the website hopefully will be super helpful and easy for you to use, as Emily mentioned, since you can just go right to each individual lesson and have your students navigate there and click right on the student activity sheets, and then use them from their tablets or MacBooks or Chromebooks or whatever it is they have. So let us know if that is working well for you in your one-to-one classrooms. It looks like a lot of you are one-to-one, so we're anxious to hear feedback about that.
All right, so if you just didn't get enough of us for this 1 hour webinar, there is opportunities to learn more about GLOBE weather. Melissa and I will actually be at Earth Educators Rendezvous in Nashville this July 15th through 19th. So please feel free to come swing by and say hi, or spread the word if you know people that are going, and say, hey, go say hi to Emily and Melissa. We'll be doing a share-a-thon as well as a teaching demo. So please come say hi and spread the word. And then also, please put it in plug for our social media, because as we maybe expand this and do more workshops, there may be more opportunities for people to do longer workshops around the country. So please do reach out to us if you have questions. Also, if you or just want to keep up to date with what we are doing. With that, I know people have been putting questions in the chat, and Melissa's doing a great job of keeping up. And but if you do have additional questions, please feel free to put them in the chat. We'll do our best to answer them. And if we don't know the answer, we're great educators and we will go find the answer for you. So we have a question about, is this the first or only comprehensive curriculum you've developed? And yes, this is our first full unit of curriculum that we've developed that's been released. We're working on a couple other things right now that aren't yet released, but this is the only one that's out there. There's another question about, is the webinar available to watch again? And yes, this webinar it's being recorded and it will be posted on the website here to view in the future. So then I wonder, we have just a short amount of time. How do you see yourself using globe weather in the classroom? I'm wondering, do you see using in the entire unit, or maybe just taking parts of it, or is weather maybe not something that you teach directly, but maybe you could relate to from other units, or wondering about implementation? What your thoughts are maybe on just this kind of quick introduction. So feel free to type in the chat if you have any comments about that, or if you have any other questions for us. Oh, great. So it looks like someone says they might try to implement some of these lessons or concepts as part of water cycle lessons. That would be a great way to do that, to make the water cycle more tangible and applicable, definitely. Oh, looks like we might see someone in Nashville. Yay! Yes, definitely come say hi if you're in Nashville. Maybe work it into chemistry or bio. Yeah, it was designed for middle school, but I used to be a high school science teacher as well. I taught earth science and biology and chemistry. And I think that a lot of these things are applicable, especially when you look at on the molecular scale, the differences between warm and cool air and all of those, and working all that into the water cycling. I think it would work. Some people are saying they don't have earth science currently in their high school, maybe not so much in their middle school right now. So maybe there would be an opportunity to bring some of these elements in some other ways. Certainly important to understand the weather, since it's something that affects us all every day, right? Thank you. Looks like somebody will be offering this as a PD, and they're sharing it with teachers who are currently training to use the GLOBE protocols. Great. So anybody who's training to use the GLOBE protocols, this is a nice extension and ways to use those protocols in lessons. Awesome. Well, thanks for all of your great comments, and thanks for tuning in today. It was so nice to have all of you here. We're really excited about globe weather, and we're looking forward to hearing stories of students engaging with the curriculum and learning about the weather. Please feel free to reach out if you have any questions, or if you're having any problems or issues with the resources, the materials, or the website. Or maybe if you just want to share some success stories or some aha moments that you and your students have had using globe weather. And I believe there's a post-webinar survey.
Yes.
Yes.
Andrew, can you put that in the chat? So we would like you to please just take a few minutes right now. It's very short, and complete this survey. It really helps us improve the webinars in the future and provide feedback to our presenters. Next slide, please. And we'd like to remind you, as we did in the chat earlier, that if you missed any of our previous webinars, you can go to our archives here. And we have, I believe it's 25 or 26 webinars now over the last 3 years that you can take a look at. This summer, professionally self-develop yourself. Please do take a moment to complete that survey. And thank you so much, Melissa and Emily.
Thank you so much.
Next slide. Once again, please watch for our announcement of our fall webinar series this summer and enjoy your summer break. Watch some of those past webinars. And next slide. Thank you for participating. And if you have an idea for an upcoming webinar, something you would like to see presented, you can put that in the survey, but you can also email any one of us. If you've completed the survey, please feel free to leave, and thank you.
Thanks again, everyone.